Alrighty, last problem on the review. Find the derivative dy dx for the ellipse given by the parametric equations. A couple different ways we could go about doing this. I'll go ahead and show you a couple of them. First thing you're probably most likely going to want to do is write this equation in rectangular form because that's most likely what you know how to do to solve this problem. So let's do that, which means I'm going to recognize first that it's an ellipse that's also told to me in the problem. But I'm going to get x plus 2 over 3 quantity squared. And then I'm going to get plus y minus 1, let's keep it consistent, y minus 1 over 4 quantity squared equals 1. Now, the first way you could go about doing this is expanding those squares if you don't remember how to use the chain rule. So let's look at that real quick. How would you do that? Well, you'd get x squared plus 4x plus 4. That whole thing still with that denominator 3, which I'm going to write as 1/3. Plus y squared minus 2y plus 1. And again, we have that denominator, which I'll write out front as 1/4, equals 1. So let's take these derivatives now. Well, the derivative of this expression with that 1/3 out front, if I multiply that 1/3 in, the derivative will be the exact same if I just multiply that 1/3 in the end. So I'm going to take the derivative now of everything on the left here, that whole thing, and also I'm going to take the derivative of the right side, which was just that 1 right there. So taking the derivative with respect to x on both sides. So the derivative of x squared is 2x plus the derivative of 4x is 4, and the derivative of 4 is 0. So I'm going to close that off, and I'm going to add that 1/4 times the derivative of y squared, which is 2y times dy dx. You have to remember to multiply your y terms by dy dx. Minus 2 is the derivative of y, but again times dy dx, and the derivative of 1 is 0, so that's done there. Equals, on the right side, the derivative of 1 is 0. We just said that. So, what can we do? Well, first off, I want to move this over by dividing it, and I want to move this over by multiplying it. So, I am going to get nothing, because I'm a huge big liar and I can't believe I just said that. It is late and I'm exhausted. How do you move this whole expression over? Well, to move that whole expression over, you need to subtract it since it's being added to that 1/4 stuff. So I'm going to rewrite this as 1/4 times 2y dy dx minus 2 dy dx equals negative 1/3 times 2x plus 4. I subtracted that to the other side. Okay, well, how do I get dy dx by itself? Well, let's factor the dy dx out of this inside stuff. If I do that, I get a dy over dx times what's left, 2y minus 2 is, let's go ahead and move this 1/4 over now by multiplying it. And that will give us, if I multiply by that denominator of 4 on both sides, I multiply by 4, I get negative 4/3 times that expression 2x plus 4. Okay, I'm getting close. How do I get dy dx by itself? Well, now I need to divide by 2y minus 2. And so I'm going to get dy over dx equals negative 4/3 times that numerator 2x plus 4 over what I'm about to divide by, 2y minus 2. There's my derivative. I'm going to simplify it a little more to get negative 4/3 times the expression. And notice 2x plus 4 and 2y minus 2, they all are multiples of 2. So I'm going to divide all of that by 2 and write it as x plus 2 over y minus 1. And there you have it. That is my beautiful derivative. And it doesn't ask us to do anything other than find the derivative. Started with parametrics, wrote it in rectangular, took the derivative. Now, you could think about how the chain rule works, if you remember that, and you could go through and use the chain rule to take the derivative of this as well. But I'm actually going to take back what I said earlier. I'm exhausted, and I'm going to stop now since we did just take that derivative. If you want to look at how the chain rule works and applies here, I believe I have a video of that on my learning guide, and you can go look there and teach yourself that. If you don't know it now, maybe just focus on the other stuff and go about this way. You could also look at your parametric equations and find a derivative using those without even using rectangular form. But you don't even know how to do that either, but you could maybe figure it out. I'd be happy to talk to you about it, but I'm too tired to do it now. I'm going to sleep.